Good morning, everyone. Today we're going to be talking about 9.4 area of regular polygons. Our learning target is I can find the area of regular polygons. So let's go ahead and get started. So, how to find the area? So this new word here, regular, we've come across it before. Regular just means that all sides are the same. So very similar to equilateral triangles. Those are regular triangles, in fact, because all sides are the same. Now we're going to be moving into more different polygons that are regular, or all sides are being the same. Of course, squares are also regular polygons. But now we're going to go into pentagons and so forth, that all are regular. So all these angles will be congruent, and all the side lengths will be congruent inside regular polygons. The area can be found by breaking the polygon apart into smaller triangles. We'll see that on the next slide. Just remember that if I need to find the area of a polygon, I can just break it down into smaller triangles, and I can find the area of each triangle if I'd like. So that's one way to go about finding the area. These areas will all have a common vertex. That vertex is in the very center of the polygon. And once you find the area of one triangle, you multiply it by however many triangles you broke it into. So if I find the area, for instance, of this purple triangle right here, then all I need to do is multiply it by, we have 1, 2, 3, 4 triangles. So I'd multiply the area of this triangle by 4, and I have the area of the entire polygon. Now, of course, we know for a square it's just base times height. But once we get into 5 sides, 6 sides, 7 sides, that's all going to change. So let's go ahead and try this out. So we have these two polygons here. These are both regular, meaning that, again, all sides are the same. All sides are congruent. If I want to find the area of this, I just put a center point right there. And I go ahead and I start drawing lines from my center to each vertex of the polygon. Now, what these lines are called that we just drew, these are called radii. So this is the radius of a polygon. And from there, I'm going to go ahead and do the same on the other one. Now, if it's an even number-sided shape, it's very easy. I just draw from one vertex to the opposite side. And as we can see, it makes all these triangles. So in our purple one, we have 1, 2, 3, 4, 5 triangles. And if we look at the sides, we have 1, 2, 3, 4, 5 sides. And for our blue, we have, of course, 6. Now, it also has 6 sides. So the number of triangles will always be the same as the number of sides that the polygon has. So if we look at this, the area would equal 5 times the area of one of these triangles. Likewise, for our 6-sided shape, the area is equal to 6, because 6 triangles, times the area of one of them. Now, this right up here, the angle, it's very important for us. So if I ever want to find any of these angles here, which will play a very key role in just a minute, all we need to do is do 360. That's how many degrees are in a full circle, right? 360 divided by the number of sides. So in this case, I have 6 sides. That means that this angle would be 60 degrees, because we have 360 divided by 6, which is equal to 60. Now, let's go ahead and create a general formula for the area of regular polygons. An apothem. An apothem is a segment drawn from the center of a polygon to the midpoint of a side. So if we go back to this previous slide over here, from the center of a polygon to the midpoint of one of the sides, meaning that it's going to be equal on both sides, and since these are isosceles triangles, I know that it will also be they'll be congruent triangles as well by side theorem. So this will be using the variable a, the apothem. So we also know that the apothem is equal to our height, so we'll be able to find the height of these triangles with the apothem. Now from here, it doesn't really matter which side it goes to, so the apothem could also be over here for triangle 1. I could draw it to any side length as long as it intersects at the midpoint. And of course, the center of the polygon. So that's what an apothem is. It's our height. It's also good to note that this is perpendicular to the side, and so it creates the height of the triangle. Now, we already talked about the radius a little bit. The radius of a polygon is a segment drawn from the center of a polygon to any vertex of the polygon. So if I were to look at this one here, it says label the apothem and the radius, find their lengths. Notice that each side is 8 on this polygon here. And then we have our apothem in blue. So this is our apothem. And in green we have our radius. Now I can draw either one or both of them if I'd like. That's perfectly fine. If I were to look at this, the first thing I want to do is I want to find the angle measure of this angle right here, this entire thing. So to do that, we go ahead and count the sides. We have 1, 2, 3, 4, 5, 6 sides. So again, we'd have, for our angle, it's equal to 360 divided by the number of sides, 6, which is equal to 60 degrees. So I know that we have 60 degrees right here. Now, the interesting thing about the apothem is that it's also an angle bisector, so it's cutting this angle in half. So this small angle right here, this purple angle, that's 30 degrees. We also know that it intersects at 90 degrees. So over where this blue angle's at, this would be 60. Oh, creates a 30, 60, 90 triangle for us. So we can go ahead and draw that out. Here's 30 on top, 60 on the side, 90 in the corner. Opposite of 90 is 2x, opposite of 30 is x, and opposite of 60 is x radical 3. Now in this case, if we're looking at this, we notice that our top length up here is 8. So that means that the bottom here, opposite of 30, is 4. So x is equal to 4, which means that our apothem is equal to 4 radical 3. So we can go ahead and put that, 4 radical 3. And then lastly, we need to find our radius length. Well, if x is 4 and the opposite 90 is 2x, well, our radius would be equal to 8. Oh, that's interesting. Our radius, our base, and our other radius are all the same, making this an equilateral triangle. So that's how we can find the apothem and the radius. Now, this works really nicely when we have a 30, 60, 90 triangle or a 45, 45, 90 triangle, but sometimes we won't always have that. And if you run into that case, think back to Unit 13 when we were doing trigonometry. You can still use trigonometry to figure out all that information. So, once again, we can look at this. If I want to find the area, I can also find the area here. So if I want to find the area of this shape, I could have done area is equal to 1/2 base, which again is one of the side lengths, times our height, which is our apothem. So this can also be written as area is equal to 1/2 our base, which I can call side 1, times our height, which is our apothem. So this area formula will work perfectly fine for finding the area of any polygon. So again, we have that right here. To find the area of any regular polygon, and again, it needs to be regular for this to work, we can do area is equal to 1/2 the apothem times the perimeter. Now you may be like, well, I was just looking at that, and you had side 1 here. This is just for this triangle. If I want to find it for the whole thing, the nice thing is that I just add up all the side lengths. I add up all the side lengths to get the perimeter, and then we multiply that perimeter by the apothem, by our height, and then of course from there we just divide it by 2. So again, area is equal to 1/2 of the apothem times the perimeter. That's for the whole shape there. So I don't actually need to count up the triangles and do all that, but you can just use this formula if you'd like, and I highly encourage you to. So let's go ahead and try this out. We have this polygon here. It's a regular polygon, and we have one of the side lengths being 12. So I know all side lengths are 12, so I can go ahead and mark that to get started. 12 feet all around, and then we can draw our radius and our apothem. So I go ahead and I just start drawing my radius. Since it's even-sided, I can just go ahead and draw from one vertex to the next. And there, we have our triangles. My apothem I'll do in green. So this is my apothem. If I want to find the perimeter, perimeter is equal to 12, because that's the side lengths, times however many side lengths there are, 6. Let's see, 12 times 6 will give us 72. So that is our perimeter. Next, let's go ahead and find that angle measure. So we're going to go ahead and find the purple angle measure so we can cut it in half and find this tiny angle measure. So again, we have 6 sides, so this is very similar to the one that we just did, 6 sides. So 360, the degrees in a circle, divided by 6 will give us 60 degrees. So again, this is a 30, 60, 90 triangle. So this little angle here would be 30, because the whole thing is 60 and it's being cut in half. This would be 60 degrees down here, and of course we have 90. Now if that's the case, one of these side lengths is just going to be 6. So this orange side length is 6 because the whole thing is 12. And again, the apothem cuts in at the midpoint, so it's cutting it perfectly in half. So from there we can draw our 30, 60, 90 triangle. So 90 degrees is 2x, 30 degrees is x, and 60 degrees is x radical 3. If we look at this, we see that opposite of 30 is 6, so x is 6. That means our apothem is 6 radical 3. All right, I think we have all the information that we need to find the area. Area is equal to 1/2 our apothem, 6 radical 3, times our perimeter, 72. We can go ahead and enter that in on our calculator. 1/2 of 6 rad 3 just gives me 3 radical 3. 3 radical 3 times 72 will give me 216 radical 3 feet squared. Because again, we're working with an area here. Go ahead and take a second, check over your work. If you pause the video, make sure that you did it correctly. Again, move on to the next one. Oh, a square. Well, we can go ahead and solve this using our area of a polygon formula, or of course you can just do area is equal to base times height. That's fine as well. But let's go ahead and get some practice in with this. So I'll go ahead and go through it the long way. So I draw my radii from one edge to the next, from one vertex to the next, and I know that in a square, because we covered this in the past, in a square diagonals intersect at 90 degrees, which means that if I were to draw my apothem, A, I would cut this angle in half to be 45. This would be 45, and of course it's perpendicular to the base, so that's 90. So we have a 45, 45, 90 triangle. Let me go ahead and draw up my 45, 45, 90 triangle over here. I know that opposite of 45 degrees is x. Opposite 90 is x radical 2. All right. Now, if we're going halfway across, we know that this would be 4. So x is equal to 4, which means that our apothem is also equal to 4. From there, we can go ahead and find our perimeter first, and then we can use our area formula. So I know that all sides are congruent in a regular polygon. So therefore, our perimeter is just 8, the side length, times however many sides, 4, which will give us 32 centimeters. Lastly, we can use our area formula. Area is equal to 1/2 our perimeter, 32, times our apothem, 4. This will give us area is equal to half of 32 is 16, times 4 will give us 64 centimeters squared. Now if you're like, okay, that works, awesome. Let's check the old way, the base times height for a square, because of course we know that way always works for us. So our base is 8, our height is 8, that will also give us 64 centimeters squared. So again, it works. It works for any shape as long as we stay consistent. Now, of course, if you're given this problem on the assessments or the homeworks or anything like that, I expect you to go the easier route for this, the 8 times 8. But I just want to make sure that we continue getting practice in this, because the more practice that we get, the more familiar you guys will be with it. So again, either way works. Simpler is always better, as long as the concept makes sense. And again, this is a good way to check to know that it works in all cases for these polygons, even the ones that we already know simpler formulas for. And again, here's our work. I didn't show this on the previous slide, the 360 divided by 4. That's also how we can find that 90 degrees, but again, we know properties of squares, so that works as well. All right, next, a 5-sided shape, a pentagon. Whoops. So, first thing I'm going to do on this pentagon is I'm going to draw my center point. The reason I do that first is because if I go straight across, I'm not actually going to have my my radius. I'm going to have a radius and an apothem. So I go ahead and I start drawing from one vertex to the next and creating all my radiuses within this shape. Now, again, it's regular. We know all sides are congruent. All sides are 12 in this case. So let's go ahead and find our perimeter first. Perimeter is equal to 12 times our 5 sides, which is equal to 60. Not 60 degrees, just 60. 60 inches, actually. Next, we need to find our apothem. So I go ahead and I draw an apothem in there. Intersects at 90. Cuts it in half. So therefore, this would be 6. From here, let's go ahead and find the angle measure of this whole angle up top here. So to do that, we do 360, the amount of degrees in a triangle, divided by the amount of sides we have, 5, which will give us 72 degrees. So the whole thing's 72. I cut 72 in half. I get 36 for this small angle here, 36 degrees. Now, let's go ahead and find out what these other angles are. So this would, of course, be 90. And then our missing angle, let's go ahead and find that. 180 minus 72 divided by 2 will give us 54 degrees. So those are both 54 degrees. And we're trying to find A. Now, in this case, we don't know any special right triangles for 36, 54, 90 triangles. So what we're going to do instead is we're going to take it back to trigonometry. Let's go ahead and write out SOHCAHTOA. And this will occur sometimes, and this is why trig's so useful for us right now. So if I were to look at this, let's go ahead and focus on angle 54. The side opposite of angle 54 is A. My adjacent would be 6. My hypotenuse is opposite the 90-degree angle. So from here, if I want to find opposite and I have adjacent, I'd use TOA, tangent. So we'd have tangent of 50, or let's just go ahead and write out our formula. Tangent of theta is equal to opposite over adjacent. So we give us tangent of our angle, which is 54 degrees. That's the angle we're focusing on in this one, 54, is equal to opposite, which is our apothem, A, divided by our adjacent, 6. Now our goal is to get A by itself. So I multiply both sides by 6. And be left with 6 tangent of 54 is equal to A. If we enter that into our calculator, we're left with 8.26. So A is equal to 8.26. Now we have our perimeter, we have our apothem. Let's go ahead and find our area. Area is equal to 1/2 our perimeter, 60, times our apothem, 8.26. If I enter that in on a calculator, we end up with our final answer of 247.8. Again, that's because I rounded this number. If I didn't round this number and I just kept what was in there, I would have gotten 247.748. But since we rounded, it changed it slightly. So keep that in mind, a slight variation on that. I would like you guys to round to the nearest, say, hundredths. Hundredths should be fine for these. And then your final answer, I'll make sure that that's included in the question. So just keep an eye out for that as well. That will be in the question for you guys. All right. Here's a difficult one. So I want to find the area of the equilateral triangle if the radius of the inscribed circle is 6. So go ahead and take a second, pause the video if you need to, try this one out, take your time on it. Very similar to the other ones, just a little bit difficult. All right, so looking at this, we notice that our apothem is 6 here. So we can already start by knowing that A is equal to 6. From here, I'm going to go ahead and draw some radii from the center to the vertexes. If I want to find out this whole big angle here, we do 360 divided by the amount of sides of the polygon, which is 3. That gives us 120 degrees. Now we also know, so this is 120 degrees here. We also know that our apothem cuts and bisects that angle into 2. So this would actually be 60 degrees here, and this would also be 60 degrees. Oh, well, if they intersect at 90, then this is 30 degrees up top. So all of a sudden we have another 30, 60, 90 triangle that we can draw. Let's go ahead and do that. 30, 60, 90 triangle, 30 up top, 60 on the left, 90 on the right. 2x is opposite 90, x is opposite 30, and x rad 3 is opposite 60. Now, I know that the side opposite 30 is our apothem, 6. And what I'm trying to find here is I'm trying to find the side length so I can find the perimeter, because I already have apothem. So, if opposite 30 is 6, that means that our side length would be 6 radical 3. So this right here is 6 radical 3, just this side. Oops. Which means that the whole thing, as you can see, is 12 radical 3. From here, we can go ahead and plug that into our formula. Area is equal to 1/2 our area times our perimeter. And to find our perimeter, I have 12 radical 3 times 3. So this whole section right here, this is just perimeter. Now, that'll give us area is equal to 1/2 times 6 will give us 3. 12 rad 3 times 3 will give us 36 rad 3. And then just multiplying 3 times 36 will give us 108. Treat the radical 3 like it's a variable, so it just stays on the end there, and we're left with area is equal to 108 radical 3 units squared. All right. Getting close to finishing. Last problem. Go ahead and try this one out on your own. Try and find the area of a square whose perimeter is 48. All right. First thing I'm going to do is I'm going to draw my square. I know that the perimeter is 48. Sorry. We know that our perimeter is 48. So if I want to find the side lengths, I do 48 divided by the amount of sides, which is 4, which will give us 12 meters per side. So each side is 12 meters. From here, well, it's the area of a square, right? So we just do area is equal to base times height. Area is equal to 12 times 12, which is equal to 144 meters squared. Ended on a nice, easy one for us. Now, of course, if you'd like to, you could draw all the radii, and then draw the apothem and find it out through that method, but you don't need to. If you guys have any questions on this, just leave some comments below, email me, whatever you guys need to do. Let me know if you need any help. Other than that, good luck, guys. Stay safe. I'll talk to you soon.